Okay, aloha everybody. So, today we're going to talk briefly about trophic interactions and energy flow. Before you guys do an activity exploring trophic interactions, I just wanted to introduce a few important concepts. So, within ecology, physical laws govern and this is very important within ecology, that physical laws govern energy flow and chemical cycling in ecosystems. And this is something that many ecologists study, is this transformation of energy and matter within ecosystems. So looking at things like nitrogen cycling and phosphorus cycling and energy cycling between different um, primary producers, such as plants, and then different animals that are consuming them and are consuming each other. So, an important physical law that applies here is the conservation of energy. Um, so, there are laws of physics and chemistry that apply to ecosystems, and in particular, today we're going to think about energy flow. The first law of energy says that energy cannot be created or destroyed, only transformed. So, if we think about a plant's not creating energy. What it's doing is it's converting or transforming the sun's energy into chemical energy, and we're doing the same thing as we eat and metabolize other animals or plants. So we're not creating energy, we're not generating energy. It's just energy can just be transformed. It can be moved from one area to another. It can't be created or destroyed. So within ecosystems, energy enters an ecosystem as solar radiation. That's a source of pretty much all energy within an ecosystem is solar radiation. Okay, so that's entering our system, which is not a closed system. We have energy, this constant energy input, and we're also radiating energy out. But that energy, that solar radiation, is conserved, and then it is also lost from organisms as heat each time it changes forms. And that's the second law of energy. This idea that transformation of energy from one form to another is inefficient. It doesn't happen perfectly. There's heat lost along the way. So here's just a schematic of this, and there's a few things I want to point out. First, energy is all flowing into this our Earth's ecosystems via the sun, and that energy is then converted into chemical energy through primary producers, okay, autotrophs, autotrophic organisms. You guys know what these are. These are plants. Plants, photosynthetic bacteria, photosynthetic protists. Um, so they are converting the energy sun into chemical energy, and that energy and those chemicals then flow throughout an ecosystem. Some of it is lost as heat, but some of that energy, as plants die, flow to detritus or turn into detritus. Okay, so detritus is just dead organic material, non-living organic material. Um, but much of it flows into primary consumers. So primary consumers are species or animals that consume primary producers. So these would be uh, vegetarians, essentially, herbivores. Some of that energy is lost as heat in primary consumers as they're performing their essential bodily functions. When primary consumers die, they become detritus. Or if they're eaten by another animal, either a secondary or a tertiary consumer, um, then that energy flows into that secondary and tertiary consumer. Some of that again is lost as heat, and then some of them also become detritus, and then microorganisms and other detritivores, so things like fungi, will consume that detritus, gain energy from that rotting, non-living organic material, and they'll also help cycle those nutrients. And then the chemicals flow throughout that system. So chemicals flow from primary consumers and secondary consumers and tertiary consumers and microorganisms and detritus back into primary producers. Okay. Uh, the distinction between secondary and tertiary consumers, which you guys will have to make in your uh, food web that you'll make in a minute, is that secondary consumers are eating primary consumers, and tertiary consumers are eating primary potentially, but also secondary consumers. So your tertiary level is always one level above the highest trophic level that you are consuming. Okay, so if you are consuming something that is a secondary consumer, you're a tertiary consumer. If you're consuming something, even if they also consume plants, even if they also consume primary consumers, they would be tertiary consumers because they're the highest level that they're eating is a secondary consumer. Um, so, an important uh, principle here as well is this idea of a trophic pyramid. And this is really helpful for thinking about how energy moves through an ecosystem and for connecting those laws of energy that we talked about with these trophic levels. So, again, producers here are at the base, they're the foundation of most ecosystems. They're harnessing the sun's energy and converting it into chemical energy. And they are most numerous. They form the most biomass. They harness the most energy overall. Above them are herbivores. Now, herbivores tend to, so less energy is available at that herbivore trophic level because some of that energy, a lot of that energy that the producers are converting from the sun is lost as that energy moves from producers to herbivores to omnivores to carnivores. And so those are terms that you're familiar with. Here's that same trophic pyramid, but thinking about it in terms of producers, primary, secondary, and tertiary consumers. So a key point here is that only about 10% of the energy from each trophic level makes it up to the next trophic level. That's in part because a lot of that energy is lost as heat, just because of inefficiencies in these biotic processes. But that's also because not all plants are being eaten by primary consumers, and not all primary consumers are being eaten by secondary consumers. So between those two things, on average, only about 10% of energy is making it from one trophic level to the next. So if we think of this in terms of kilocalories, if you've got 1,000 kilocalories of producers, only about 100 of those kilocalories are going to make it up to a primary consumer level. Only about 10 are going to make it up to the secondary consumer level. And then only 1 is going to make it up to that tertiary consumer level. So this also explains things like, population sizes. So if you look at top predators, these tertiary consumers, they often need really large habitats, really large home ranges in order to get enough energy from those trophic levels that are beneath them. And as a result, they oftentimes have much smaller population sizes. And as a result, they're much more likely to be threatened or endangered. And what makes that even worse is the fact that they rely on all of the trophic levels beneath them. So a tertiary consumer relies on the secondary consumers directly, and then indirectly they rely on the primary consumers and the primary producers. So if anything happens, if the habitat is degraded in any way, then that sort of has this compounding effect as it moves up those trophic levels. And that's why we see so many tertiary consumers, these large predators, these top predators being threatened. I also want you to think about this in terms of the impact that your diet has on the environment and why a carnivorous diet as a human, or a diet that's heavy with meat, why that has a larger impact, why that has a bigger impact on the environment. So a quick note about detritus. So when things die, they become non-living organic matter, and detritivores, or decomposers, are the ones that are critical members of these ecosystems because they derive their energy from detritus, and they help connect all of those different trophic levels by breaking up that energy, by consuming that energy, by breaking up and recycling those nutrients that are essential for all levels of those different ecosystems. So prokaryotes and fungi are really important, and many ecosystems, some ecosystems rely on primary producers as sort of their foundation. Other ecosystems rely on detritus as their foundation, so rotting organic material that the rest of the ecosystem builds on. So there's a little group work now for you guys to do. So there's a worksheet that I want you guys to work through, and Emery will help you guys walk through the first step or so of that food web and make sure that you're okay building that food web. And I want you to be able to do this. If I give you a food web, I want you to be able to interpret it and figure out, well, what's the primary producer on here? What are the primary consumers, secondary consumers, tertiary consumers? Be able to build one if I asked you to build one, and be able to understand, most importantly, what happens when we remove an individual from that food web, and that's pretty critical. And this kind of links back to some of those ideas when we talk, and is going to also link into some of the ideas when we talk about conservation at the end of the semester. Why each species is critical, even if we don't rely on it directly. This is like a big house of cards. If you remove one card, might be okay. Move two cards, three cards. Pretty soon that house of cards might come crumbling down, and food webs are very similar to that. So good luck on your activity. Have a great time, and I will talk to you guys later.